Bismillahirrahmanirrahim. In this session, we will discuss thermal properties and temperature from Tom Duncan and Heather Kennett book for O-level and IGCSE students. And this book is published by Hodder Education. And here you have test yourself questions from page 102 from this book. And here we have the first questions. Explain why the metal lid on a glass jam jar can be unscrewed easily if the jar is inverted for a few seconds with the lid in very hot water. In the kitchen, the answer is that simple. In the kitchen, a tight metal lid can be removed from a glass jar by immersing the lid in the hot water so that it will expand and loosen. So on getting the temperature, this will expand. So this expansion will help us to open the jar easily. So this thermal expansion helps to open the lid easily. The part B, the furniture may creak at night after a warm day. The temperature changes causes the wood, metal and other material in a house structure to expand and contract, resulting in an ominous creaks. So this happens because of the temperature variations. This phenomena occurs because of a temperature variation, expansion and contraction of the material. Part C, the concrete roads are laid in section with pitch and compressible filing between them. Why do we lay in a sections? Because to allow space for thermal expansion so that necessary expansion and contraction can be accommodated. So this actually we do this because of this expansion and contraction accommodation within this called lead roads. Question number 2, we have a bimetallic strip is made from aluminum and copper. When heated, it bends in this direction as shown in figure 2.25. So this is aluminum and this is copper, and after heating it will expand like this. Which metal expands more for the same rise in temperature, aluminum or copper? Aluminum expands more. Aluminum expands more than copper for same temperature rise because of its thermal expansion. Sketch diagram to show how the bimetallic strip would appear if it were cooled to below room temperature. Aluminum contract more on cooling as compared to the copper. Now question, test yourself from page 104. Explain the relative order of magnitude and expansion of solid, liquid and gases. The linear expansion of solid is small and the effect to be noticed, and the solid must be long and or the temperature change must be large. With a large variation in temperature, this solid expansion or contraction will occur. For a 1 meter length of steel, the linear expansion is 0.012 millimeter for a 1 degree temperature rise. So the particles in a liquid are further apart, less ordered. This is a solid case. For a liquid, the particles are further apart, less ordered and are more mobile than in a solid. So the interaction between the particles is less and expansion is easier for liquid than the solid. Liquid typically expands about 5 times more than the solid. So this expansion will be more with the temperature, given temperature rise. In gases, the interaction between the particles are few because they are far apart. So interaction is very low, very small interactions exist in gases. So they are because they are very far apart away and move very quickly. This means they are able to expand much more easily than liquid. Typically the gas expands 20 times more than the liquid. So that's 100 times more than the solid. So this is very large. Expansion occurs because of the temperature rise. This indicates that gas expands much more readily than liquid, and liquid expands more readily than solid. what is meant by the anomalous expansion of water. This is very, very important phenomena that helps to live the uh, marine objects or marine animals. As water is marine life, as water is cooled to 4 degrees Celsius, it contracts. Up till this, it contracts. So we are cooling from high temperature to lower temperature. So its volume is decreasing. Volume is decreasing with the cooling. So the temperature is reducing and its volume is reducing. So density is increasing. Water, however, between 4 degrees C and 0 C, it expands, but after which it expands. At 4 degrees C, with the decreasing temperature, the volume will decrease. Volume will decrease because at this point the volume is this, but with the rising temperature, with the decreasing temperature, the volume is decreases, and with the decreasing in temperature, the density will be high at this point. But afterward, if we decrease the further temperature, its volume will increase. So it will expand surprisingly. The water has a maximum density at 4 degrees C as shown in this figure. At 0 degrees C, it freezes. At 0 degrees C, at this temperature, it freezes. A considerable volume expansion occurs. So from this, expansion occurs, and at every 100 centimeter cube of water becomes 109 centimeter cube. So the 9 centimeter cube of ice is, the volume is 9% higher than this water, liquid water. So name two consequences of unusual expansion of water. The account for the bursting of unlagged water pipes in very cold weather, and for the fact that ice is less dense than cold water and so floats. Figure 2.27 shows a bottle of frozen milk, the main constituent of which is water. So on expansion, this will expand. After 4 degrees C, the water expands, as we see here. So as a result, this will expand. So the unusual anomalous expansion of water between 4 degrees C and 0 C explained why fish survive in frozen pond. So why fish survive? Because the water at the top of the pond cools first. At the top of the pond, the cool first. Here, at the top of the pond, it cools first. Contract, and being dense sink to the bottom. So with the cooling, the temperature becomes density will be higher, and that water drops to at the lower position, and the light water, the frozen, will comes to the upper surface. So being dense contracts, and being denser sink to the bottom, and the warmer, less dense water rises to the surface of the cooled surface to be cooled. When all the water is at 4 degrees C, the circulation stops. When all the water is at 4 degrees C, the circulation stops and it becomes less dense and remains at the top, eventually forming a layer of ice at 0 degrees C at the top position. Here at the surface, it becomes 0 degrees C, and at the bottom we have 4 degrees C. Here the fish survive at these places because of denser water at 4 degrees C, and at the top scale the light water, and this is a scaling of ice at the top, and here at the bottom having relatively dense water with a temperature of 4 degrees C, and that helps to survive the marine life, especially the fish. The volume expansion of water 4 degree to C is due to the breaking up of the group that water particles from above 4 degrees C. The new arrangement requires a large volume and more than cancel out the contraction due to the fall in temperature. So this is the behavior of the water. As a result, this. Now describe the action of a liquid in a glass thermometer. In glass thermometer, the liquid in a glass bulb expands up a capillary tube when the bulb is heated. When bulb is heated, it will expand in the liquid will expand in the capillary tube. The liquid must be easily seen and must expand or contract rapidly by a large amount over a wide range of temperature. It must not stick to inside the tube, or the reading will be too high when the temperature is falling. So the mercury and colored alcohols are commonly used liquid in this type of thermometer. Mercury freezes at -39 Celsius and boils at 357 Celsius, but is a toxic material. So this is very harmful. It's a non-toxic metal alloy substitute for mercury. A Gallinston is often used nowadays. It melts at -19 degrees C and boils at 1300 C. Alcohol freezes at -115 Celsius and boils at 78 Celsius, and therefore more suitable for low temperatures. So those alcohol type thermometers are used in low temperatures. So that's all from this part, and in the next session we will discuss some